Hi. So a long-time subscriber of the channel, Lee, sent me this Renogy DC to DC converter. And what it's used for in his camper van, it can charge various different types of batteries from either the vehicle's alternator or from solar panels if you've got solar panels on the roof. So he said he was away on a camping trip and it just died and it shows no signs of life. So I think what we'll do is we'll connect it up to the bench power supply and then we'll see exactly what it's doing. So this is where the battery connects to. And this is the positive input from either the solar PV or the alternator. So we'll connect the bench power supply up to where the battery goes, and that should make it spring to life and show the battery status level. I've got it hooked up to the bench power supply, so let's just switch that on. And it is drawn about 140, 150 milliamps or so, but there's no lights on it. It just seems completely dead. Now, I know he's already been into this and he's had a look inside and he can't see any obvious signs of anything blown. So let's pull it apart and let's see if we can discover anything. Let's switch this bench power supply off. And I think there's some screws on the back. I think there's about 8 screws because I think there's a couple down here as well. So let's remove those. Right, so let's see if this bit comes off. We've got some thermal pads there. And looks like we've got an insulation sheet. Let's get that out of the way. And we're into it. So let's just zoom down a bit, see if we can see anything obvious. So it looks like we've got a main microcontroller or something here. Yeah, microchip there, just briefly saw. So that might be the main brains of the unit. Looks like we've got a number of MOSFETs dotted about. So we've got some current sense resistors here. And that looks about it. So I think there's another board further down by the look of things. So I might have to get that board out as well. So I'll see if I can remove these 4 bolts and then we'll see what's underneath here. Right, so we have, looks like a couple of big inductors there, some capacitors. And this is the main control panel. So the fault might be actually on the main control panel. Let's see if we can unplug this. We'll get this board out and then we'll connect the power supply up again and then we'll try measuring some voltages or something, I think. Let's see if we can get this board out. When he first sent us the email, I was a bit concerned that it might have been all potted and full of goo because I know some of the Victron PPT controllers are, but it looks like this one isn't, so that's good. Right, what have we got on here then? Possibly some kind of voltage regulator there. So I think this is for communications. There's a little transformer there. Looks like a couple of opto-isolators. And these are the LEDs, which seem to run down to this chip here. And there's also a footprint, I think that's for a Bluetooth module. So I can see TM16 something or other there. So I think that's kind of like a display controller, if I remember. Because I've came across one of those in something else. With some conformal coating over this part of the board. But I can't see any signs of obvious damage on this either. Right, let's plug this back into the other board and then we'll put some power and we'll see if we can measure some voltages. I've got the bench power supply hooked up. I'm just going to switch it on. So I've got 12 volts going in there. Let's use this as a ground. Let's just see if we get anything on this voltage regulator. Got something there, just conformal coating. Got 1.4 on that pin and 0.5 on that. Well, that seems rather low. I'm pretty sure that's a voltage regulator. So I wonder if there's a fuse or something, or a fusible resistor gone round here, possibly. I'm going to see if I can get the pin out of this microcontroller, and then we'll be to measure the voltage because we'll know what pins VCC and that is. And we'll also get this under the microscope so we can get a little bit closer look at it, I think. So I've got it under the microscope here and I've managed to clean off the conformal coating just to see what chip this is. So it's a DS-PIC33 P64GS504. And the power comes in on these two pins here and also a couple of pins over here as well. But we should just be to measure if we get any voltage on these two pins here. So let's try and scrape these off a little bit because this conformal coating is in the way. That might do. So let's just switch it on. I'll just go into volts DC. I'm only getting half a volt on the microcontroller. I wonder if that is the same as what we get on here. So let's just try that. Because this is indeed a voltage regulator. And yes. So I think this is the voltage regulator for the microcontroller. But it doesn't appear that we're getting power into it, I don't think. I'm just trying to get past this conformal coating. So there's only 1.3 volts going into this voltage regulator. And this is a 3.3 volt regulator, which is why we're only getting half a volt out of it. So we have a resistor here. Let's just see if we get power coming into here. 1.3 or 1.4 volts going into here. So I was wondering if that resistor had kind of failed. Right, I'm just going to switch this off a sec. Let's just go on to resistance and let's just see what we get between ground and here. We've got about 100 ohms. Let's just see what we get between ground and the output. Let's just hope it's not the microcontroller has failed. Well, that actually looks okay. So it seems to be on the input side of here. So I need to trace where the power comes into this resistor. So that resistor goes to via here. And if we just flip the board over, I think it's that one there, which then goes through a 3.3 ohm resistor and then just disappears. We do have another little power supply here by the look of it. Looks like some little buck converter maybe. Let's see if we can see anything else on this side of the board. So I wonder if we're getting voltages on that. I might hook the power up again and we'll just see if we get any voltages. Possibly this might be the input here. And that's probably the output where the inductor is. It's just this conformal coating is a bit of a nightmare, that's all. Right, I'll hook the power back up again and we'll try and measure some voltages on here. Right, I've just got the power supply on. I'm just going to volts DC. Let's get a ground point. Actually, that's the PV input that comes from here. That's what that one is. Mm, 1.4. What was the voltage we were getting on the input of this regulator? About 1.4. So is that regulator fed from this little circuit? Is there something wrong with this? I don't know where the power comes into this circuit though. And this is on this capacitor. Let's see what we get on this one. I can fight through the conformal coating. So that must be the input, and we've got nearly 12 volts there. But we've only got 1.3 on the output. And if that's feeding that regulator, I would have thought we should have more than that. Might get the thermal camera on it. We'll have a look at this under the thermal camera, I think. Right, I've got the thermal camera out. Let's just switch this on. And what's that? There's something getting warm there. Switch that off a second. Yeah, there's something about 50 degrees there. I think that might be it. Let's see if I can get a bit closer view of that. So I think it's that capacitor just there. I'll just try and switch it on again. And there you can see it just lighting up just there, just to the left of this cotton bud. I think it's that first out capacitor's failed. Let's just zoom down a bit. So that capacitor there, I think the very first one coming from the inductor. Let's just go on to resistance and just see what we get across it. It's not completely short. We've got about 88 ohms there. And that's about the reading I was getting on the voltage regulator on the other side of the board. Right, I'll get this under the microscope and we'll try taking that capacitor off. So I've just used a little grinding pen to try and get rid of some of the conformal coating off this capacitor. Let's just see if we can heat it up. Just try and get rid of this bit of solder that got splattered on here. Right, let's see what the resistance measures across these 2 points now. And we've got K. About 1.2 K now. And before we had about 80 ohms or less. Yeah, 82 ohms on that capacitor. Now, I'm not sure what value it is. We'll have to see if we can figure out if we can replace it. I mean, it'll probably work fine without it, but, you know, we might as well replace it. So I'll see if I can take another one off and then we'll try and figure out what value it is. Right, let's see what it measures. It looks like 10 microfarad. Right, so I would assume that all three of these are going to be 10 microfarad. I've got some replacement capacitors, so let's heat this up and we'll get those fitted. I'll just give that a bit of a clean up with some IPA. That looks fine to me. Right, let's see what it does now then, if anything. Right, let's get it hooked up with the bench power supply then and see what it does now. Right, I'm just about to switch it on. Hey, we've got some lights. And that changes when you press the button. Excellent, so I think that might be it. So we'll put it back together and then we'll just give it a final test and I think that'll do. Right, it's all back together. So it looks like the whole device was rendered useless by a tiny shorted capacitor. So that's a few times now I've had devices rendered useless by shorted capacitors. I think there's been a solid state hard drive, a EV charger, this and a couple of other units now. So if you've had a problem with shorted capacitors, let me know in the comments below.